So we are starting a new unit today. Our new unit is called quadrilaterals. What do you think of when you hear quadrilateral? Yes, you think of four. Quad means four. So we're studying shapes that have four sides. And you should have a family tree in front of you. Does everyone have a family tree? Your family tree should look like this. And this one sheet of paper is precious. Guard it with your life for the next unit. This paper is going to house all of the properties for all of the quadrilaterals that we are focusing on in this unit. You'll keep them all in one place. That way you won't have to thumb through your notes, and slowly throughout the unit you are going to memorize this whole page. You will, believe it or not, you will. All right, let's look at the warm-up. ABCD is a parallelogram. Using your prior knowledge, we're trying to decide if these statements are true or false, using what you already know about parallelograms. All right. AD is equal to BC. So, true or false? What do y'all think? Of course it is. Yes, it is true. And I could even prove that to you. Well, a very informal proof. I could smartboard prove it to you if I could draw straight lines. And I could trace those segments. And then I could lay one, oh, look at that, perfect match. So yes, AD is congruent to BC. In other words, AD is equal to BC. All right, number two, angle A, the whole angle, not a part of it, is congruent to angle C. Ooh, what do y'all think about that one? All right, very good. It is true. The second one is true as well. And I could smartboard prove that one as well by tracing the angle and doing some little rotation magic. And by golly, it is exactly the same. Awesome. All right, next one. Those diagonals are congruent. Some of my students didn't know what a diagonal was. Those are the dotted lines. BD is a diagonal and AC is a diagonal. Number three is false. No one spoke up. I bet some of you maybe were thinking it was false, but you didn't say anything. It is false, guys. Look at those dotted lines. Look at them. They don't look the same length, do they? I mean, maybe they do. Maybe they do too. So here's BD. Let's just compare this guy. When I rotate it, do I change the length of it? No, of course not. All right, and here's AC. Let's look at this guy right here. We're really doing today's lesson in the warm-up, by the way, so that's cool. Oh my goodness, do those look like they're the same length? No, the diagonals are not congruent. Not in a parallelogram, they're not, because he's leaning. And when he leans over, I'm calling it a him, I don't know why. When he leans over, that produces inequality for the diagonals, the tilt. Yep. Last one, number four, line AB is, y'all remember what that symbol means? Parallel to line DC. Well, I would sure hope that they're parallel since the shape is called a parallelogram. Let's hope that they're parallel. All right. We're going to take notes now. You need quite a few things on your desk. You need your good old family tree that you're going to keep in a really safe spot and is going to become your best friend for the unit. You need your little handout that has some proofs on it. And then you just need wherever you take notes. You need that out as well. Let's look at all of these just for fun. I know you probably learned this in middle school. Okay, quadrilateral, a polygon with four sides. Let's meet our quadrilaterals. Welcome. First one is parallelogram. So that's what a parallelogram looks like. The second one is, of course, a good old square. This third one is a rectangle. This fourth one, good old trapezoid. Ooh, what's this next one? What's this one? A rhombus. This is a rhombus. I know, it doesn't have markings on it. I know. And what's this last one? We're going to learn about this one last. Not a diamond. None of them are called diamonds yet. It's called a kite. I mean, they're all on your family tree, so they were right there for you. But yes, that one is actually called a kite. Like, that's the real geometry word for it. Yep, sure is. All right. So, welcome to the quadrilateral family tree. So this kind of works like a real family tree. It's like everyone's last name is quadrilateral. And then there's different parents and different kids on this family tree. So the way a family tree works is that shape is itself and it's everyone above it. So for example, a rectangle. What is a rectangle? Well, a rectangle is a rectangle, but it's also a parallelogram because that's above it, and it's also a quadrilateral. So a rectangle really could have 3 different names. It has 3 different qualifications. What about an isosceles trapezoid? It's an isosceles trapezoid. It's, of course, a trapezoid, and it's a quadrilateral. What about a square? They're married because they're side by side. I don't really know. A square is a rectangle, then it's a rhombus, and it's a parallelogram, and it's a quadrilateral. Oh my gosh, that square has got it going on. Woo! That is a special shape. Excuse me. All right, we'll learn about those on Friday. Today it is all about the parallelogram. If you're titling your notes, you're going to write parallelograms. If you've ever ridden a school bus, you are thankful that parallelograms exist because the lift that lifts them up to work on a school bus underneath, it's in the shape of a parallelogram. Yep. The next time you're bored, you can take your bag of chips and you can figure out if you can copy this person and fold it into the shape of a parallelogram. This one's really pretty. I forgot where this was. Pretend I remembered. But it's a restaurant overlooking a lake. And the architect chose to make it in the shape of a parallelogram because parallelograms are awesome. Anyways, so yes, they are in the real world. Yes, we see them. Parallelograms have 5 properties. 5. We're going to memorize them, and hopefully you'll memorize these in the next couple days because then you'll have more to memorize later. Let's see if we can just look at the symbols alone, and name all 5 properties. Don't write them on your family tree yet. We're going to get to that in just 1 minute, okay? So don't write anything down. Okay, you're already running away with it. All right, what do these symbols mean? Yep, you said it. That means opposite sides are parallel. You have to know that those arrows mean parallel. They don't mean congruent. They mean parallel, same slope. Okay, the next one. This is saying that sides are congruent. You have to be really specific with these properties. No, not just sides are congruent. The opposite sides are congruent. The opposite sides are congruent. This next one, what do arcs mean when we put an arc on an angle? Trying to show you that they are the same measure, right? Congruent, yep. So, same thing, opposite angles are congruent. So, for the first 3 properties, I use the word opposite all 3 times. Opposite sides parallel, opposite sides congruent, opposite angles congruent. Now, we need to name this one right here. What am I trying to show by this one right here, and what should we call it? You notice about 110 and 70. Good. Good. They're supplementary, right? 110 plus 70 is 180. That's not a coincidence. That happened on purpose. So we want to say that these angles are supplementary, but they're not opposite angles. We have to use a word to describe them. We can't just say supplementary angles, right? So which ones add up to 180? Which ones are supplementary? Good, Aaliyah. They are same side interior angles, and that's a really good observation. That's not what we're going to call them on our property list. But that's a really good observation. Remember this? Parallel lines in a transversal, angle 1 and angle 2, were same side interior angles. So we need to use a word, and it needs to not be opposite, and it starts with a C. Have y'all ever heard of that word, consecutive? All right, so we're just using the word consecutive to mean in a row. Consecutive angles are supplementary. So what that means is that this angle and this angle are supplementary. They're not opposite. They're in a row if I were going around. This angle and this angle are supplementary. They're not opposite of each other. They're in a row. So consecutive means like in order, in a row. So as you go around your parallelogram, the ones that are next to each other, kind of, not adjacent, but consecutive, those are supplementary. Okay, we spent plenty of time with that one. Let's look at this last one right here. What is that trying to say? What are those symbols trying to communicate to us about a parallelogram? Y'all are all saying good things. The midpoint of one diagonal is the midpoint of the other diagonal. Diagonal splits the other into congruent halves. Okay, what's the word for that? There's a word. The diagonals. Good, Neil. They bisect each other. Remember this symbol lowercase b with a circle around it, it means bisect. So that last one is saying the diagonals cut each other in half. The diagonals bisect each other. Are they equal in length? No, I put 2 tick marks and then, the set of 1 tick marks, but they do cut each other in half even if they aren't equal in length. All right. So boom, here's a summary of your 5 properties. I want you to write these down on your family tree. And I do want you to note that this first one it's property number 1, but it's also the definition of a parallelogram. So that's important for you to know that yes, it's a property, but it's also the definition. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. That is the definition of a parallelogram. So when you're writing these properties, to be able to write it quicker, you can use symbols like parallel and congruent, and you can use this for angle and this for bisect. So you have lots of symbols at your disposal for when you want to shorthand write these in your notes. All right, this next slide, it's not really an additional property, but it's going to take the properties that we just learned about, and we're going to prove additional things. Yes, I said prove, yes. Not on this slide, but in a couple of slides we're going to prove something. First, let's just kind of discover something. If quadrilateral ABCD is a parallelogram, what do you know about triangle ABD? So I'm just going to call it triangle 1, this triangle right here, and CDB. Mark the picture. All right, let's look at our properties. Opposite sides are parallel. Okay, guys, you're giving away the punchline. Yes, they're congruent, but we have to show they're congruent. We can't just be like, yeah, I think those are congruent. We have to show it. Opposite sides are parallel. Now, that's all good and fine, but parallel won't really help us prove congruent unless we're doing some angles in there. So, let's go to our next property on the list. Opposite sides are congruent. Opposite sides are congruent. And then what about BD? BD is congruent to BD. Reflexive property of equality? No, not CPCTC. Reflexive property of equality. And boom, they are congruent by side, side, side. We could have gone a totally separate route. We could have said opposite angles are congruent before we did reflexive, and we could have said, hey, they're congruent by side, angle, side. So it is very, very easy to see that these 2 triangles, yes, they are congruent. So when you draw the diagonal of a parallelogram, you divide the parallelogram into 2 congruent triangles. That's just kind of like, oh, cool, that's good to know, but no, you don't have to memorize that. We will use CPCTC today, Anas. We will. It just didn't fit right there, okay? Welcome back, proofs. It's been a while. So yes, in this unit, we are going to integrate some proofs because this is a perfect unit to take those properties and find out why are those properties true. They didn't just fall into someone's lap, right? Pythagoras wasn't just sitting there and be like, oh, yay, it's raining parallelogram properties. No, someone proved it, someone discovered it. So we're going to do that as well, and it gives us a deeper understanding of the shapes while we're at it. So this proof says, prove that the opposite sides of a parallelogram are congruent. That's property number 2. We don't want to take it for granted. We want to actually prove it. Okay, so remember with a proof, you always start with a given and you end with the prove. You start with a given, you end with the prove. So you should never get number 1 or number last one wrong, ever. So, statement ABCD is a parallelogram. We stole that from here. And the reason is always given. That part was handed to us, given. All right, statement number 2. This is weird. We've never seen this in a proof. Draw DB. Well, okay, let's just do what it says. I can follow directions. Draw DB. The reason is because through any 2 points, there's exactly 1 line. So that one's kind of silly. We won't make you ever fill that one in yourself. Draw DB. We drew it. Okay, cool. What's the next statement? AB is parallel to DC. Okay. And AD is parallel to BC. We made a statement. Now we have to say why we were allowed to make that statement. Why were we allowed to say statement number 3? And I told you this in your notes. It is the definition of a parallelogram. The definition of a parallelogram is opposite sides are parallel, since the word is parallel in the name, parallelogram. All right, next one. ADB is congruent to CBD. Do you see how I'm marking my picture as I go? That's pretty important. All right, and this angle is congruent to this angle. Alrighty, we made a statement, now we have to back it up. Why are we allowed to say number 4 is true? Very good, you got it. Because if we have parallel lines, then alternate interior angles are congruent. It's not a property, it's a theorem, sorry. Alternate interior angle theorem. Yep, that's why. That's the only correct answer. Okay, next one. DB is congruent to DB. Reason is, very good. This one comes up a lot, almost every proof. Reflexive property of equality. If you just put reflexive property, that'd be okay too. All right. Number 6, they changed it up on us. They gave us the reason, they didn't give us the statement. When we say ASA, angle, side, angle, when that's our reason, what was our statement? When we cite angle, side, angle, what were we saying? Right? We're saying that 2 triangles are congruent. Yep. You can name them any way you want. I'll call the first one DAB. Once you name the first one, the order that you name the second one is very important. So if I do DAB, then I would have to do BCD. And that's because angle, side, angle. All right, finally, we are saying that the opposite sides are congruent. Look at that. We are saying what we wanted to say. Oh, I am thinking of a song now. Say what you want to say. Okay, anyways. And the answer is, y'all said it earlier today. All right, the reason is because corresponding parts of congruent triangles are congruent. When you go past saying triangles are congruent, the reason is always, almost always, CPCTC. When you've proved them congruent and you're going past that, the reason is almost always corresponding parts of congruent triangles are congruent. So I'm saving this proof until the very end because of time. Let's get to some examples. Given quadrilateral ABCD, blah, blah, blah. Find the perimeter of ABCD. Okay, now let me tell you what's important. I specifically did not label this parallelogram because I want to teach you how to label a quadrilateral. You can start anywhere you want to start. You can put A here, you can put A anywhere you want. The only thing you're not allowed to do when naming quadrilaterals is jump across the quadrilateral. So like A, B, C, D. Nope, that will automatically force your answer to be wrong. You never jump across. You can go clockwise, you can go counterclockwise, it doesn't matter, but you need to name it in a circular fashion, okay? A, B, C, D. Could I have gone the other way and still get the answer right? Absolutely. All right, so AD is 6x minus 3. AB is 5x, and BC is 4x plus 17. Find the perimeter. Every time you do something in this unit, I want you to mentally justify it to yourself. Like, okay, I'm setting these 2 things equal, and I'm allowed to do this because ... Because then you'll just start setting things equal, and you won't know why you're doing it, and you'll set things equal that aren't supposed to be equal. Okay? So, I'm going to set this equal, and I know exactly why. Because property number 2, opposite sides are congruent, right? That's why I'm allowed to do that. It says it on my family tree. Very nice. X is 10. We plug that bad boy in. 6 times 10 minus 3. Opposite sides are congruent. Plug it into AB. Opposite sides are congruent. Look at that. Now we have an addition problem on our hands. Final answer? Come on, guys. Yeah, there we go. I was waiting for someone to type it. Good job. 214. Very nice. All right, example number 2. This one's named for you. These, even though they're not labeled, these are the angle measures. Cool thing about a parallelogram is that when you know one of the 4 angles, you actually know all 4 angles. So you only need to know one in order to know all 4 of them. Property number 3 tells us opposite angles are congruent. Yay! So we can set those equal. X is 5. I don't really care about the algebra part. I know y'all can handle the algebra part. I just want to make sure you have the geometry part of it. Okay, so we plug it back in. This angle ends up being, what, 20 degrees when you plug it back in? Like I said, you know one angle, you know all angles, so let's do it. Opposite angles are congruent, 20, 20. Consecutive angles are supplementary. What's the supplement of 20? You got it. 160. Opposite angles are congruent, 160. So we know all angles. Alrighty, moving on. Whoa, now we have some diagonals drawn in our figure. I want you to find all missing angles. There's 9 of them. See if you can find 9 of them. Alright, let's go over it. Here we go. Alternate interior angles, 18 degrees, 18 degrees. I'm allowed to do that because I have parallel lines. If I didn't have parallel lines, I can't use the alternate interior angle theorem. Okay, let's do it again. 25, 25, 88, 88. And now I think I've exhausted all of my alternate interior angles for now. There's a lot of ways to find the remaining missing angles. Here's the tougher way to find it. You could say, oh, this angle and this angle, those are consecutive angles, so they're supplementary. So I could find all of angle A, and then I could subtract 88 from it, or I could add all those up and subtract from 180. Or you could use triangles, which you're going to have to do a little bit of anyways. You use the triangle sum theorem. You can add up 25 and 88 and subtract from 180, and you have 67. Vertical angle theorem, 67. Linear pair theorem, let's see, 113. Vertical angle theorem, 113. And then to get this angle right here, you could just do triangle sum theorem again, unless you wanted to use your consecutive angles. Lots of different avenues, same destination. 49, and then good old alternate interior angles, 49, 49. And that is a quadrilateral full of angles. All right, try this one. The answer is 120. The answer is 120. So you can call angle B X. Angle C is double angle B. Oh, that's easy. So it's 2x. And then you can add them to equal 180 because consecutive angles are supplementary. You see how before I do anything I say a property, like what property is allowing me to do that? 3x equals 180. X is 60. Therefore, C is 120 and opposite angles are congruent, 120, 120. All right, one more problem and then we'll go back to that proof and then we're done for today. How would we start this one? Well, we kind of already did a problem like this. We would begin by using our good old alternate interior angles because we know that those are congruent because we have parallel lines. So we can start there. Solve for y. So I'm getting y is 5. We can't plug that in for x, so we have to be careful. Plug that y back in, 6 times 5 plus 5. Of course, we don't need to plug it in because it's 35, alternate interior angles. Now there's a few things that we could do. I want to use one of my properties though. So I know that this angle and this angle, I know they add up to 180. So I'm going to take my 80 and my 35, 115. So I'm going to say 5x plus 115 equals 180. Because this whole angle plus this whole angle equals 180. One way to do it. 13, I'm getting 13. All right, 180 minus 115 divided by 5. Okay, let's go back to that proof now. So I wanted you to see one that was a flowchart proof since we have never done one of these before. Not that it's any different, it's just your information is organized differently. It's not the different information, it's just how it's organized. Notice in this flowchart proof, they gave us all the reasons. They're all there. We need to make the statements. They already gave the reasons. What are we even trying to do? Prove that the diagonals of a parallelogram bisect each other. All right. What are we given to work with? Okay, we're given ABCD is a parallelogram. Sorry for my shorthand notation, my abbreviating. All right, so check, given. Cool. All right, now we kind of flow the information. Let's go down this side of the flow chart. We need to say something, and the answer, the reason, is definition of parallelogram. What could we say that would be the definition of parallelogram? Well, I know the definition of a parallelogram is that opposite sides are parallel. So I'm going to write down that the opposite sides are parallel. I'll mark my picture because when I say something's true, I should mark it. Why are they parallel? Definition of parallelogram. Let's keep going with that flow of knowledge. Let's stay on that side of the proof. We need to say something, and we need to use the alternate interior angles theorem. Now, I added these numbers to my proof just because I'm trying to make it easier on us, especially since this is the first time we're doing it this way. So add those numbers to your picture as well, please. Add those numbers. And then we're not having to name the angles with 3 letters because that gets a little messy, especially when they didn't give us much room. So give me a pair of alternate interior angles. Good. We can now say angle 2 is congruent to angle 4. And angle 1 is congruent to angle 3. Let's mark it on our picture because when we say something, we want to mark it. Good. Okay, we can't go anywhere else until we fill in the right side. Okay, what does this say? Opposite sides of a parallelogram are congruent. So what do we want to say? That's listing one of the properties. That's property number 2, right? So we want to say exactly what we did on the other side, except we're going to use a congruent symbol instead of a parallel symbol. There we go. So tick mark. Tick mark. Now we need to say something, and the reason is angle, side, angle, congruence theorem. Well, look at that. Do you see it? Angle, side, angle. And look up here. Angle, side, angle. So we need to name those little bitty triangles. Let's name them. Triangle, I'll call it AEB, is congruent to triangle CED by angle, side, angle. And then you always start with the given and you always end with the proof. So we're going to just plagiarize the proof. We don't even have to think about it. We just rewrite it. AE is congruent to EC by CPCTC. What were we even trying to do? Do you remember? We were trying to say that the diagonals bisect each other. So we only proved that one diagonal got bisected, but don't worry. You use the same logic and show that the other one was bisected as well. Yay!